moving on to areas of circles and sectors. The last section, the two sections you guys did were areas of triangles, parallelograms, rectangles, rhombuses, squares, kites, trapezoids, well, I said rhombus, there was one I may have forgotten, but anyway, all of those, yeah, kites, rhombus, trapezoid, blah, blah, blah. All those old figures that you guys probably had when you were little. So now we're going to talk about circles and this new thing called sectors. And so let me give you the vocabulary terms that we're going to use. We're going to use sector. I'm going to show you segment, but we're not actually going to find the area this year of a segment just because of time, but we'll do a sector. Okay, so if you have a pizza delivered to your house, for instance, at my house, and this is true, every Friday night is pizza night, and we get pizza from different places. And when the pizza is delivered, there are usually pieces of pizza like this that look like these triangular kind of regions, or maybe you've played Trivial Pursuit and you've noticed these little pie regions. But unless you order from like Pizza King, which cuts theirs in little squares, most pizzas are cut into what's called a sector. So at my house, when a kid wants a piece of pizza when they were little, I would make them ask for a sector. And then once they said, Mom, can I have a sector? I'd say, sure, help yourself. But they'd have to ask for that. That way, when they got to this lesson, they knew that a piece of pizza is a sector. So that's what a piece of pizza is. It's a sector of a circle. So let's fill in the proper definition. By the way, that's not really a true story. So a region of a circle bounded by a central angle. So you have a central angle right here, and you have its intercepted arc or the minor arc. So if you look at the definition, it says the sector of a circle is a region that's bound by a central angle and its minor arc. And then these sides right here will be radii because it's a central angle. Okay? So a slice of circular pizza is an example of a sector of a circle. So be looking on that for that on your test, because I usually like you guys to know that a piece of pizza is a sector if it's cut like this. All right, we will be finding areas of those. Now I'm going to show you one other piece of a pizza where maybe you eat your pizza like this, but we're not going to actually find the area this year. It's called a segment. It's kind of interesting. So go around, make a circle, and then what I want you to do is I want you to make a sector like we just did. And then I want you to cut off like the crust. So basically make a triangle with those radii. And then this little section right here, that's called a segment. So a segment of a circle is kind of like part of a sector. It's kind of like you take off the crust part, which basically, or you take off this triangle part and what's left is the crust. So the definition is it's a region of a circle bounded by an arc and a chord. So you have an arc right here and a chord, and that's going to make a segment. Now, you don't really need to know that this year. I'm just showing you where it is because we're not going to be finding the area of that. Some years we do, but this year we're just going to find the area of the sector. All right, so before we look at sectors, let's go down to what you guys probably know about with circles. And I asked you before I started this video if you guys knew the formula for area of a circle. Most of you know that's pi r squared. Okay. Keep in mind you are now squaring. It's not 2 pi r. So let's review the circumference formula. Circumference is 2 pi r or pi d. And then area is pi r squared. You're going to be using both of those a little bit in this section. Circumference will pop up in a couple questions. All right, a couple of examples of just basic area of a circle. So example 1, what is the area of the putting green shown to the nearest square foot? Okay, now keep in mind when you go to do area of a circle, you cannot use the diameter like you did with circumference. So you have to find the radius. There's no choice. So if you take this diameter of this putting green and you do 20 divided by 2, you will get the radius of 10. So we're going to do the formula area equals pi 10 squared. All right, well, if I wanted an exact answer, my answer would be 100 pi. That's the exact answer. But since they asked us to go to the nearest square foot, we're actually going to type it in. So we're going to type in 100 pi, and we're going to go to the nearest square foot. So normally I would round to the nearest tenth, but they want the nearest square foot, so it's 314. So 314 would be the nearest square foot. And then let's go put our units back on. So this was measured in feet, so it's going to be feet squared. Okay, so that's example 1. Let's move to example 2. You're going to skip this one and try it after the video. So we'll skip and try example 2. Find the radius of a circle if I give you the area. All right, so now you can see that we're going to be starting to go backwards, which is a little more challenging than what you did when you were little. So I'm going to take 95 and I'm going to set it equal to pi r squared. All right, now if there had been a pi right here, it would be so money because we could just divide by pi and cancel, but there is no pi to cancel with over here. So we need to solve for r, so the first thing we're going to do is divide by pi. And yes, we're going to have to type that in. So try to use the pi key on your calculator because that's the most exact. If you want to use 3.14, you can do that also. 95 divided by pi. So this is about 30.2. So I'm going to put 30.2 equals r squared. Now, unlike the circumference formula that we had, this time we have to undo the squared. So we are going to square root both sides. So one thing you can do in your calculator is you can square root 30.2 as it is on this screen. So watch how you could do this. I mean, you could retype it in, but just so you know how to use your calculator a little bit better. I could go second square root, second, and then down here it says answer. And that's going to type in the screen from before, and it's going to square root what I had on the screen before, which is kind of cool because you don't have to retype anything in. So second square root, second answer. If you don't want to do it, it's fine. Just retype it in. It's 5.5. So our radius is 5.5 centimeters. So that's how you work backwards with the area formula. And that should feel pretty easy because we've done it with circumference. All right, so you're going to skip the you try for now, and you're going to come back and do it at the end of the video. All right, so now we're going to step up the game a little bit. So let's pretend like an entire pizza was sent to your house and you ate the whole thing, which would make you a pretty big hog, but you would be eating pi r squared, right? Well, most kids and people they're not going to eat the whole pizza. You're going to have the pizza delivered and you're going to eat a sector or 2 or 3 or maybe 4 if you're hungry, but usually you don't eat the whole thing. So when we find the area of a sector, you might notice that the formula down here looks a lot like arc length. So I'm going to write it's like arc length, which was in chapter 10. So the difference is we're doing the degree over 360, but notice that behind here is not 2 pi r or pi d, it's pi r squared. So picture if the whole circle was delivered to your house and you ate the whole thing, you would be eating pi r squared. But if you don't eat the whole thing and you only eat this many degrees, then you're going to be eating x out of 360 times pi r squared. So you're eating a fraction of the circle instead of the whole stinking pizza, which would be really bad if you ate the whole thing. So think of it as a fraction of the area. And that will give you this sector piece that you're eating. Now, just to review, arc length is the length of the arc, and area of the sector is the area of the whole piece. They're totally different from each other. So arc length is if you're walking around the outside, and area of the sector is if you're eating the piece of pizza, which is more fun than walking, right? Eating. Okay, so let's go over to example 3 so I can show you an example of area of a sector. Okay, so it says a circular pizza, so draw your circle, has a diameter of 12 inches. So let's draw our diameter. Now, I'm not going to use the diameter because pi r squared, you can't use the diameter. So I'm going to go ahead and make the radius 6 inches instead of using the 12. And it's cut into 8 congruent slices. Okay, so now I have 2, and then I'm going to cut my pizza the other way, and that makes 4. And then I'm going to cut those in half, and those in half. And I'm going to end up with 8 slices of pizza. So if you get a pizza delivered or you have a frozen pizza and it's cut into 8 slices, it would look like this. It says, what is the area of 1 slice to the nearest hundredth? So you're basically going to be eating 1 slice. All right, so I'm going to give you a couple of options on what you could do. So the formula is area of a sector equals x over 360 times pi r squared. And remember, the x is the degree. Now, what I could do is I could find the degree of all of these little angles in here, but I want to show you another way you could do it. So the first thing I notice is I ate, what fraction of the circle did I eat? Well, I ate 1 slice out of 8. So you could just go 1/8 and not worry about doing the degree, because that is 1/8 of the whole circle or the whole area, times pi 6 squared. Or if you don't like that and you want to do the degree, just think of this as going 360 divided by 8 would make each of those pieces of pizza a degree of 45. So each of these little central angles would be 45s. So if you'd rather do 45 over 360 times pi 6 squared, that's fine too. Both of those are going to give you the same answer, either 1/8 of the whole pizza or 45 out of 360. All right, so let's type it in, and we're going to round to the nearest hundredth. So we're going to type everything in. So 45 divided by 360 times pi times 6 squared. And we're going to get 14.14. And they wanted it to the nearest hundredth, so I'll leave it like that, 14.14. So the area is 14.14. And then I go back and look at my units, and it's inches squared because I'm dealing with area now and not arc length. So this is area instead of arc length. All right, so on the You Try, I'm just going to do one of these with you, and you're going to come back and try these by yourself in just a little bit. So let's go to this one. So ding dong, the pizza's delivered. Yay, everybody's having pizza. But you decided to eat a huge amount of this pizza. Okay, so the formula for the area of this much that you ate that's shaded is area equals x over 360 times pi r squared. And remember, x is degree. How many degrees out of 360 you ate? Okay, so you have to be careful on these. Kids get growing really fast and like, oh, 65 over 360. Well, no, you're lying if you say you ate 65. That's how much was left for everyone else. You ate all of this. So you need to actually take 360 and minus off the 65 and be really honest with yourself. You ate 295 degrees, which is a lot more than the 65 that's there. Okay, so you're going to say that the area is, you ate 295 out of 360 times pi 11 squared. When you type this in, it's just like arc length, only it's going to give you the area of the pizza that you ate, which is more fun than walking around the outside of the circle. 295 divided by 360 times pi, and you can do it individually or all together, times 11 squared is 121, so I'll just type it in that way. And you're going to get 311.5 if you're going to the nearest tenth. So the area is 311.5 inches squared. And that's the area of the pizza that you ate. So congratulations. All right. Down here, we're going to just do a couple more examples with sectors because they're the hardest. So on this one, it says that if the diameter of a wheel is 10 inches and each section, each of the 12 sections is congruent, find the area covered by the green hues. So you can't tell what's green, but this is green. So I'll make it green for you. So you can do this a couple ways. You know the formula is area equals x over 360 times pi r squared. So you can either find the degree and times it by 3, or you can ask yourself, how many sections is this out of 12? So when you notice, do you guys see how this is 1, 2, 3 sections? So I'm actually going to not worry about doing the degree. I'm just going to say that I have 3/12 of the circle covered in green, which is 1/4. And I'm not going to worry about the degree because I already know it's a quarter of the circle that is shaded in. So I'm going to do 3/12 times pi. And then remember, if the diameter is 10, your radius is 5 squared. So you can make this 1/4, or you can leave it 3/12, and then you're just going to type it in. 1 divided by 4 times pi times 25. So the part of the wheel that's green is 19.6 square inches. So the area is 19.6 inches squared. If you want to do it with degrees, just take 360 divided by 12 and then times by 3, because there are 3 sections there. All right, so the last thing we're going to look over are two problems where we're going to work backwards. These are the most challenging. Just like with arc length, you have to go backwards. So let's look at these two. All right, so what it's saying is it wants you to find x, which is the diameter. And this part is shaded. You just can't see it very well, but we're going to assume that that half is shaded. Okay, so I'm going to set up my formula. Area equals x over 360 times pi r squared. Now, check this out. They gave you the area, so you're going to put in 66 for the area. How many degrees is your sector? Oh, it's 180. So you can put 180 over 360, or you can make it 1/2, because it's half the circle, times pi, and then r squared. Well, r is going to be, I'm going to leave it r squared, because if I put x there, I might think x is the radius, but it's the diameter. So at the end of the problem, I'm going to need to double it to get my diameter. Okay, so we need to solve this, and we've done this before just with circumference and not area. So I'm going to move my fraction to the other side. I'm going to go ahead and make this 1/2. Just think it's going to be easier to work with 1/2 than 180 over 360. All right, so if I want to move my half to the other side, I'm going to times by 2. So picture multiplying by the reciprocal, and that's going to move the 1/2. So 66, if you're going to times by 2, that's going to give you 132 equals pi r squared. Now, I'm still trying to find r, so I'm going to divide by pi. And yes, I'm going to have to type that in. So I'm going to do 132 divided by pi, 42 point blah, blah, blah. So let's do 42. 42 equals r squared. Then I'm going to square root both sides because I'm undoing the squared. So I can go second square root 42, or you could hit second square root, second answer if you want. And you're going to get about 6.5 for your radius. Now, the reason why I did that is because look what you're trying to find. You actually want to find your diameter. So this is 6.5. So to get your diameter, we've got to times by 2. And so x is 12 centimeters. So that's a working backwards problem. Again, it's the same thing you did before, it's just with area. Okay, last example. Again, we're going to work backwards. So this time we're going to do area equals x over 360 times pi r squared. But we're going to put in, oh, did I miss, thank you, 13. I was like, what are you talking about? I mismultiplied there, so thank you for saving me. 13. All right, so I just wrote my formula out. Now I'm going to put in all of the values that I know. So I know my area, so that's going in for A, so 94. I don't know my degree this time, so that's going to stay x up there instead of being where the radius was. But I do know my radius, so that's going to go pi 14 squared. So again, this is just algebra. Okay, so you can do this in whatever order you want. I'm going to times by 360. I'm going to divide by pi, and I'm going to divide by 14 squared. So let me show you what you can do to do this, and I want to give you a helpful piece of information here. So if I'm going to first times by 360, I like to move that first. So that's 33840. 33840 equals, and then if you don't remember what 14 squared is, it's 196. So I'm going to make this 196 pi. And then there's an x over there also, because I moved my 360, but the x is still there. Okay, now watch this. I'm doing this on purpose because I want to remind you. If you would like to divide by multiple things at once, I told you this before, you have to put them in parentheses. So you're going to type this in, but you got to put it in a parenthesis. When you do that, you should end up getting about 55 degrees for x. And again, you don't have to solve the way I did. Just make sure you're getting x by itself. Okay, so now what you're going to do is go back and finish any ones that we skipped so that you can practice doing them on your own to see if you can get them right.